In the second part of section 7.1, we want to talk about completing the square. The completing the square method is a method that we can use if we would like to use the square root method to solve, but we have that pesky linear term. And we know that if we want to use the square root method, we cannot have a linear term in our problems. We can use a method called completing the square. And when we say completing the square, we're talking about a perfect square trinomial. When we think back to how we factored trinomials, we use the reverse FOIL method. And x squared plus 8x plus 16, if I do reverse FOIL, we know that we can do x and x, and then we have positive and positive, and then 16. We can do 1 and 16, 4 and 4, 2 and 8. In this case, 4 and 4 is what's going to work. And we call it a perfect square trinomial because we know that we can write x plus 4 times x plus 4 as x plus 4 squared. So x plus 4 times itself gives us what we would call a perfect square trinomial. So x squared plus 8x plus 16 is a perfect square trinomial. Why is this helpful? Well, it's helpful because 8x is a linear term. So we started out with 3 terms where one of them was a linear term. And you notice that when we end up with our final answer here factored, is that x plus 4 squared, this is just a quadratic term. This is one big quadratic term. So we went from something that had a linear term to something that was just a quadratic term, which is exactly what we need to do in order to solve using the square root method. We want to get rid of that linear term. Now the next one, when I go to factor this with reverse FOIL, we have x and x. Our signs, since the last one is positive, the middle sign is negative, then we know they're both going to be negative. And for 25, we have 1 and 25. Or 5 and 5. In this case, 5 and 5 will work. And we know that x minus 5 times itself can be written as x minus 5 squared. Once again, we started out with something that was a linear term, and now we have just one big quadratic term. So factoring, in this case, a perfect square trinomial allows us to eliminate the linear term and have just one big quadratic term. One of the things I want you to notice before we move on is the relationship between the number associated with a linear term. So we started out with 8 as the number in our linear term, and I want you to notice the factorization. When we go to factor a perfect square trinomial, the number that will be inside of the parentheses with the variable will always be half of the linear term. Let's look at the second one and see that the same rule applies. We started out with a negative 10. What is half of negative 10? Well, that is negative 5. What goes inside of the parentheses when I factor is actually a really quick way to factor is just to take half of the linear term, and whatever half of that linear term is, that's what ends up going in the parentheses when I factor a perfect square trinomial. That's going to be helpful to us in a few minutes. Here are 5 steps for solving using completing the square. The first 4 steps are steps that will work to eliminate the linear term. Once the linear term is gone, then we can actually solve using the square root method. Let's look at our first example. Here we have x squared plus 4x minus 12 equals 0. We want to solve this eventually. We want to solve this by using the square root method. However, we're not allowed to do it right now because of the fact that we have this linear term, 4x. So we need to eliminate that linear term. In order to do that, we're going to follow a few steps. So here's the process. Our process will be, the first step is to write the equation in this form where we have the variables on one side and the constant on the other. So the first thing I'm going to do is I'm going to add 12 to both sides. The reason we're doing that is because what we originally had was not a perfect square trinomial. It would not have factored as a binomial squared. So we want to create this perfect square trinomial by first of all getting rid of the number that doesn't give us that perfect square trinomial. So get rid of that 12, put it on the other side, so that we can actually create the perfect square trinomial ourselves. So we move the 12 to the other side, and remember that whatever you do to one side of an equation, you have to do the same thing to the other side. Step 2 will be to make sure that whatever's in front of x squared, we want that to be a positive 1. That step for this example is already done for us. That will be more important later. The next thing that we want to do is to complete that perfect square trinomial. So what I'm going to do is I'm going to take my equation and I'm going to give myself a little bit of room after the 4x. We're going to add something in. We're going to add a number in, and we're going to add this to both sides. So I'm going to give myself a little room on both sides. We're going to add something in to create this perfect square trinomial. So what we're going to do is we're going to take half of the linear coefficient. So we're going to take this 4 and I'm going to half it, which is the same thing as multiplying by 4, or multiplying by a half, sorry. 1/2 times 4 would give me 2. So this is the half of that linear coefficient. Before I go and put it into my equation, I'm going to square it. So we half it and then square it. So first we half it and then we square it. And I'm going to put that number in both sides of my equation. If I add 4 to the left-hand side, I also have to add 4 to the right-hand side of my equation. So make sure that when you half it and square it, we add that to both sides. We never subtract it, we're always adding it to both sides. Now I want to factor that trinomial. I have just created a perfect square trinomial on the left-hand side. How does that factor? X squared plus 4x plus 4. Let's talk about it for a second in the long way of factoring. The long way of factoring would be to say, let's factor that using reverse FOIL. That would be x plus 2 times x plus 2. And we could check that to make sure that it does give us that correct middle term. That would be one way to go about factoring, and then we know that x plus 2, that would be x plus 2 squared. I want to get a little bit faster with this, especially later on, and we want to start to recognize a faster way of being able to write it as this binomial squared. We have created a perfect square trinomial so that it will factor as a binomial squared. So let's go ahead and write it as a binomial squared. The variable comes first, and we want to look at the half that we took. When we halved the 4, that was a positive 4, we got a positive 2. The half that we took will be the number that's included inside of the parentheses. This is going to be a little bit faster way to actually factor that, and then later on we will want to just look back at the half we took and put it inside of the parentheses as a quick way of factoring it. So we have rewritten x squared plus 4x plus 4. We have factored that. So you want to know where those 4's went. Well, we factored it. We took that trinomial, we factored it, x plus 2 squared. If you were to multiply that out, remember you would get right back to where we started. Now on the other side, 12 plus 4, we get 16. So we want to simplify and factor. Factor the left-hand side, simplify the right-hand side. Now what do you notice? Now we have a quadratic term and we have a constant term. We have eliminated that linear term. And the whole purpose of that, once again, was to be able to use the square root method. So now I have x plus 2 squared equals 16. I'm just going to go ahead and write that down again. Now we will use the square root method by taking the square root of both sides. I have x plus 2. We take the square root of x plus 2 squared. We get x plus 2 equals, now what's the thing I don't want to forget? Right, my plus and minus. and the square root of 16 is 4. Now, do I need to write this as two totally separate equations, or can I just keep the plus and minus in and write it as one answer? Now, we want to be careful. We want to know if I subtract the two, are these like terms? And the answer is yes, they are like terms. So I do want to combine them, but I can't combine them if I'm considering that to be a positive 4 and a negative 4 at the same time. So I will need to separate. We will write this as x plus 2 equals positive 4, x plus 2 equals negative 4, and now I can actually subtract the 2 from both sides of each one of those equations and find my solution. We get x equals 2 as one of my solutions. And on the other side, when we go to subtract 2, combining my like terms, I get x is equal to negative 6.